Hello everyone, I guess you have gone through my last video which dealt with lines, points and angles. Let's revise before we start today's concepts. We came across points, we came across lines. So line has no points, line segment has two endpoints. Line is nothing but a line segment which can be extended in both the directions. Then we came across angles. Any lines that intersect with each other give rise to angles. There are different types of angles: complementary angles, where the pair of angles sum to 90 degree, supplementary angles, where the pair of angles sum to 180 degree. Adjacent angles are those angles where there is a common point or the vertex, there is a common side and two non-common sides. Adjacent angles which equal to 180 degree are called linear pair. Vertically opposite angles are those angles which fall on the opposite side. So these two are vertically opposite angles and these two are vertically opposite angles. We also came across intersection, intersecting lines and parallel lines, which we will be taking a very closer look in this class. Intersecting lines. A very common example is the letter Y. Here we see that if this is a line and this is a line, they are intersecting at this common point. Another very common example is the case of a chessboard. There are many lines which are intersected at many different points. Hence, for two lines L and M, the intersection is given by O. Consider this case where there are many lines and then many intersections. So B is an intersection point, C is an intersection point, B is another intersection point, E is another intersection point. So we can say that two lines intersect if they have a point in common. Let's move to transversal. In day-to-day life, we see that as a main road and there are some roads which are joining the main road. So the main road can be called as the transversal because it cuts the sub-roads. These are the intersecting points. This when taken in case of our example, L and M are the lines and P is nothing but the transversal. Here we can see that P is a line or P can be a transversal which cuts other two lines, or L can be a transversal which cuts P and M. So any two lines can be cut by another line which is called as a transversal. Like yesterday, we will be learning new terms today. 3, 4, 5, 6 are the angles that fall within L and M, and these are called the interior angles. The angles that fall outside these are called the exterior angles, and they are 1, 2, 7 and 8. 3 and 6 are on the opposite side of the transversal, but they are interior angles, so they are called pair of alternate interior angles. Similarly, 5 and 4, which fall on opposite side, which are interior angles, so they are alternate interior angles. Similarly, for exterior angles, 1 and 8 fall on the opposite side, so they are the pair of alternate exterior angles. 7 and 2 are the pair of alternate exterior angles. 3 and 5 fall on the same side of the transversal. 4 and 6 fall on the same side of the transversal, so the pairs are called as pairs of interior angles on the same side of the transversal. So these are the interior angles, these are the exterior angles, these are the alternate interior angles, these are alternate exterior angles, these are pair of interior angles on the same side of the transversal. So we saw transversal of lines. Now we will move into transversal of parallel lines. In yesterday's class, we studied that parallel lines are those lines which are never going to intersect. A very common example is a railway track. We see that these two are never going to intersect at any point. Another common example in our day-to-day life is a ladder. These two are the lines that are never going to intersect. But the steps can be considered as transversal because they are intersecting the parallel lines at these locations. Another common example is a window. These lines are parallel lines and these are the transversal which cut the parallel lines. So we'll look into lines example. If this line L and M, if this is a transversal, then this is cutting at these 2 points. Similarly, if this is a transversal and these two are lines L and M, these are the points where the transversal cuts L and M. And these angles that the transversal makes are called the corresponding angles. So, if in case L is a line and M is another line and they are parallel, it means that L by a shift of some amount gives rise to M. So whatever the angles that it had made over the 4 directions are nothing but the same which are made here. Once again, if L is one line and M is another line and they are parallel, it just means that one line is moved down, or if M is the line and if it has been moved up, then it becomes L, which totally means these angles should be equal. And as already I have called them the corresponding angles, 7 and 8 are corresponding angles, 1 and 2 are corresponding angles, 4 and 3 are corresponding angles, 6 and 5 are corresponding angles. But by the concept that I taught you, which means that 7 and 8 should be equal, 1 and 2 must be equal, 4 and 3 must be equal, 6 and 5 must be equal. So this is one of the results that we will be studying today, which can be applied to solve many problems. So if 2 parallel lines are cut by a transversal, each pair of corresponding angles are equal in measure. In the same diagram, we come across vertically opposite angles. 3 and 7 are vertically opposite angles, 4 and 8 are vertically opposite angles, 5 and 1 are, 6 and 2 are. So, we know that vertically opposite angles, all these angles, these pairs are equal. And also from this result, where it says that corresponding angles are equal, 7 is equal to 8, 1 is equal to 2, 5 is equal to 6, 3 is equal to 4. 5, 6, 7, 8, 1, 2, 3, 4. These measures are equal. From these two, we see that 3 is equal to 7. But from this result, we have 7 is equal to 8. So 3 is equal to 7, 7 is equal to 8, which means that 3 is equal to 8. So 3 is equal to 8. What are these? 3 and 8 are pair of alternate interior angles. Similarly 1 is equal to 5 and 5 is equal to 6, so 1 is equal to 6. So 1 and 6 are pair of alternate interior angles. So from this result, we have that when parallel lines are cut by a transversal, then the pair of alternate interior angles are equal. These two. Using this result, we can derive one more result. So we know that 1 and 3 are on the same side. This is a common vertex. These two are non-common sides. This is a common side. So they make linear pairs. So 1 plus 3 is 180 degree. But we know that 1 is equal to 6. So 6 plus 3 is 180 degree. But these two angles fall on the same side of the transversal, which makes the angles that fall, interior angles on the same side of the transversal, will be equal to 180 degree, or interior angles on the same side of the transversal are supplementary. Similarly, 6 plus 8 form a linear pair. 6 plus 8 should be supplementary, but 6 is equal to 1, pair of alternate interior angles. So 1 plus 8 is equal to 180 degree, and these fall on the same side of the transversal. So pair of interior angles on the same side of transversal make them supplementary. And this will be the third result. So in other words, if two parallel lines are cut by a transversal, each pair of alternate interior angles are equal. Also, if two parallel lines are cut by a transversal, each pair of interior angles on the same side of the transversal are supplementary. Let's move ahead. If A plus B is equal to C plus D, we can say that C plus D is equal to A plus B. That is, we studied that if two parallel lines are cut by a transversal line, then there are corresponding angles which are equal alternate interior angles which are equal and interior angles on the same side of the transversal are supplementary, which means that if there are two lines and if there is a transversal, if the corresponding angles are equal, or if the pair of alternate interior angles are equal, or if the interior angles on the same side of the transversal are supplementary, then these two lines are parallel. So using any of these relation, using any of this result, we will be able to prove that two lines are parallel. So there is top to down approach and bottom to down approach to prove lines are parallel, or using parallel lines we can prove this result. In order to better understand or better remember the results, there's a shortcut. So these are corresponding angles. So corresponding angles always form a shape of F. In this case, F is this. So these are the corresponding angles. In case of alternate interior angles, there is a pattern of Z. So these two, and these two, and these two. So alternate interior angles are Z and corresponding angles are F. Let's move on to some examples and problems. So in this case, it's given that L is parallel to M and we have to find X. We know that if this is Y and X are corresponding angles, so Y should be equal to X, but this is a linear pair, so this must be equal to 180 degree, which means Y is equal to 70 degree, which means X is equal to 70 degree. Once again, L and M are parallel. 110 is the angle that we know. We have to find X. So any angle that corresponds with 180 degree on this side of L will be equal to 180 degree because that is a linear pair. So Y is nothing but 180 minus 110, that is 70. But Y is equal to X because they are corresponding angles. So X is equal to 70 degree. Let's move to the next example. Sometimes there are some data that are given which will not be required for us. This is a similar case. There are two lines A and B. There are two more lines L and M. We see that there are two measures that are given 100 and 80 degree. But in order to find X, 100 is just sufficient because we know L is parallel to M, A is the transversal. These are corresponding angles, so X is equal to 100 degree. Okay. It is an extension of the previous question and the concept is very familiar with you. It's given ABC is 70 degree. We have to find DGC. And it's given these two are parallel lines. So it is nothing but what you have learned. This is a transversal, these two are parallel lines. And this is the angle that is given. And this is the angle that has to be found. X is equal to 70 degree because they are corresponding angles. So it is a very simple problem. Let's move on to the next question. We have to prove L is parallel to M and H is a transversal. So we know H is a transversal, but we have to prove L is parallel to M, given 126 degrees and 44 degrees. We have studied that if this is a transversal, if they are parallel lines, then the angles on the same side of the transversal should be equal to 180 degree. So let's check if 126 plus 44 is equal to 180 degree. So this is 10 and 3. It is not equal to 180 degree, which means L is not parallel to M. So let's move to the next question. Even here we have to prove L and M where N is transversal. There are two angles that are given 75 degree each. So let's suppose this is Y 75 plus y is equal to 180 degree. So y is 180 minus 75, that will be equal to 105 degree. But if L and M are parallel, we wanted y to be equal to 75 degree because they are corresponding angles, but y is not equal to 75 degree, which means L is not parallel to M. So every problem here relied on the concept of corresponding angles if we saw. So in order for two lines to be parallel, we need to check if they have equal corresponding angles or equal alternate interior angles, or the angles on the same side of the transversal should be equal to 180 degree. Let's move to next problem. All this time we were either identifying a single angle, or with the help of single angle with the given angle we were able to justify certain reasons. In this case, P and Q are parallel lines. 125 degrees is the angle that has been given, and we have to find the rest of the angles that are mentioned here in letters. We know that 125 should be equal to D because they are corresponding angles, and D plus F should be equal to 180 degree because they both are on the same side of the transversal and they are interior angles. So D plus phi is 180 degree, but D is 125 degree, so F should be 55 degree. So F is 55, D is 125, and D and C are linear pair, so or F is equal to C because they are corresponding angles, so this is also 55. And then D and B are equal because they are vertically opposite angles, so this is 125 degree. And pair of alternate interior angles should be equal, so F is equal to A, so this is also same 55 degree. E is equal to A because they are the corresponding angles, so this is also 55 degree. So we have found everything. Though the problem looks very huge, it is very simple. So let's go again. 125 should be equal to D, corresponding angles. 125 plus F should be equal to 180 degree, linear pair. So 125 plus F, 180, F is 55, F and C are equal, corresponding angles. And then these two are vertically opposite angles, these are equal. And then from these two we get linear pair, or these two are interior angles which are opposite, so these two are equal. These two are corresponding angles. So this is how we are going to apply the concepts and find the angles that are unknown to us. So we found that if two pairs of parallel lines are given which are cut by a transversal, then the corresponding angles are equal, alternate interior angles are equal, and the interior angles that fall on the same side of the transversal must be equal to 180 degree.